Welcome to the Core Stream. The BYE podcast presents Matrix. Complexity reduced to logic, structured elements.
BYE Matrix, Episode 5, The Anatomy of Quantum Mechanics. Welcome back to the BYE Matrix. If you have initiated this fifth transmission, you possess the cognitive bandwidth required for an uncompromising deconstruction of reality. Today, we discard the illusory comfort of Newtonian determinism and interface directly with the subatomic bedrock of existence, quantum physics. We are not here to indulge in simplified analogies, we are here to interrogate the underlying mathematical scaffolding of the universe, from wave-particle duality and probability amplitudes to the fundamental indeterminacy operating at the Planck scale. Prepare your neural pathways for a severe paradigm shift. The threshold has been crossed. BYE Matrix is now active. We now arrive at the most profoundly disturbing phenomenon in the entire quantum framework, entanglement. Albert Einstein, famously resistant to the ontological implications of quantum mechanics, derisively labeled it spooky action at a distance. Yet, its reality is fundamentally indisputable and mathematically rigorous. To comprehend entanglement, we must completely abandon the classical, intuitive concept of local realism and spatial separation as the defining characteristics of isolated physical systems. When two or more subatomic particles interact in a specific manner, their independent quantum states are irrevocably obliterated. They become entangled, meaning their physical properties must be described entirely in reference to one another. From that precise moment of interaction, it is a mathematical fallacy to speak of particle A or particle B as independent entities possessing isolated, inherent properties. Mathematically, the composite system must now be represented by a single, non-separable wave function. In the strict formalism of quantum mechanics, this composite state vector resides within a vastly expanded Hilbert space, constructed specifically through the tensor product of the individual Hilbert spaces of the original constituent particles. This is not simple addition, it is a multiplicative explosion of dimensional complexity. Let us consider the classic example of a bipartite system, two spin-half particles, perhaps an electron and a positron, created simultaneously in a singlet state. The mathematics governing the conservation of angular momentum strictly dictate that the total spin of this isolated system must be exactly zero. Therefore, the system exists in a coherent superposition of mutually exclusive possibilities. If particle A is spin up, particle B must be spin down, and conversely, if particle A is spin down, particle B must be a spin up. Crucially, prior to measurement, neither particle possesses a definitive spin direction. The unforgiving mathematics of the entangled wave function dictate that the moment a macroscopic apparatus measures particle A and forces its wave function to collapse into a definitive spin-up eigenstate, particle B instantaneously, inevitably, and flawlessly assumes a spin-down configuration along that exact same measurement axis. This physical correlation is absolute and perfect. The profoundly unsettling nature of this phenomenon lies in its blatant and unapologetic disregard for the relativistic speed limit of the cosmos. If we were to separate these two entangled particles by a distance of 10,000 light-years, the measurement performed on particle A still instantly collapses the global wave function of the entire composite system. The specific state of particle B is defined in zero time. There is no physical signal transmitted through the vast expanse of intervening space, there is no classical mechanism of communication propagating at or below the speed of light. The particles behave as a singular, unified physical entity fundamentally extended across the spatial dimensions, ignoring the illusion of distance. This non-local correlation permanently shatters the foundational Newtonian and Einsteinian assumption that an event occurring in one specific region of space can only influence a distant region after a time delay governed by the speed of light. In 1935, Einstein, alongside Boris Podolsky and Nathan Rosen, formulated the celebrated EPR paradox specifically to weaponize this instantaneous correlation against quantum mechanics. They argued eloquently that because information cannot travel faster than light, the outcome of the measurement on particle B must have been predetermined at the precise moment the particles were initially entangled. They posited the existence of hidden variables, unknown, unmeasured classical properties embedded deeply within the particles at their creation that strictly predetermined their future outcomes, thereby preserving local realism and deterministic certainty. The EPR paper was not a rejection of the mathematics, but a philosophical declaration that the quantum mechanical description of physical reality was demonstrably incomplete. However, as we shall soon discover, the subatomic universe is far more counterintuitive and mathematically ruthless than Einstein was ever prepared to accept. The equations do not merely describe our ignorance of a pre-existing, hidden state, they describe a reality where the physical properties of entangled systems are genuinely, ontologically undefined until the exact moment of catastrophic intervention by the observer. We must plunge substantially deeper into the epistemological rupture that quantum mechanics demands. To comprehend the subatomic realm, you must entirely jettison the comforting, tangible concepts of classical mechanics. There are no minuscule billiard balls orbiting microscopic suns. Such imagery is a profound distortion. We are interfacing with pure, unadulterated mathematical abstraction that dictates physical reality. Let us interrogate the fundamental bedrock of this architecture, the state vector, and the complex mathematical landscape it inhabits. In classical mechanics, defining a system is a straightforward matter of establishing precise spatial coordinates and momentum vectors within a phase space. In the quantum regime, however, the physical state of an isolated system is exhaustively encapsulated by its wave function, denoted by the Greek letter psi. It is imperative to understand that this wave function is not a physical wave propagating through a tangible medium, analogous to sound waves in the air or ripples in a pond. It is, rather, a complex-valued probability amplitude. To map this mathematically, physicists employ a formidable construct known as a Hilbert space. Visualize, if your cognitive architecture allows, an abstract, infinite-dimensional vector space mapped over the field of complex numbers. Within this expanse, every conceivable physical state of a quantum system is represented as a definitive unit vector. Furthermore, the mutually exclusive outcomes of any potential measurement correspond to strictly orthogonal basis vectors within this infinite space. This rigorous geometric framework brings us directly to the widely misunderstood phenomenon of quantum superposition. Popular culture incessantly reduces this to the banal, almost insulting oversimplification of an object existing in two distinct places simultaneously. We must eradicate this misconception. Superposition is a strict mathematical property inherent to linear differential equations. Because the governing equations of quantum mechanics are strictly linear, any linear combination of valid solutions is itself an equally valid solution. Therefore, prior to the disruptive intervention of a macroscopic measurement apparatus, the system exists as a coherent linear superposition of all permissible eigenstates. The particle is emphatically not physically smeared across the universe. Instead, the universe maintains a meticulous, ongoing accounting of complex probabilities, where the precise phase relationship between these distinct states allows for constructive and destructive interference, a phenomenon that is entirely absent in the realm of classical probability. The deterministic evolution of these probability amplitudes is governed with absolute precision by the Schrödinger equation. This is not a suggestion, it is a rigorous partial differential equation that directly relates the time derivative of the wave function to the action of the Hamiltonian operator. The Hamiltonian serves as the supreme mathematical dictate of the system, encoding the absolute totality of its kinetic and potential energy. When we track a quantum system over time without observing it, we are not tracking a physical object traversing space, we are calculating the continuous, deterministic propagation of a complex probability field. To bridge this majestic, unobservable mathematical formalism with empirical, physical reality, we must rely upon the Born rule. This rule dictates that the probability density of finding a system in a given state is equal to the absolute square of the wave function's complex amplitude. We are indeed dealing with probabilities, but we must differentiate this from the classical probabilities of ignorance that govern a coin toss or the roll of a die. Classical probability arises merely because we lack sufficient data regarding the initial parameters and forces. Quantum probability is altogether different, it is fundamental, irreducible, and purely ontological. The definitive information regarding a specific measurement outcome simply does not exist anywhere in the universe until the act of measurement is physically performed. Finally, this mathematical scaffolding forces us to confront a severe operational constraint permanently codified in Heisenberg's uncertainty principle. It is vital to banish the elementary notion that this principle is merely an artifact of clumsy experimental technique or a consequence of the observer's physical instruments disturbing a delicate system. It is an intrinsic, fundamental property of waves and non-commuting mathematical operators. Consider the conjugate variables of position and momentum. In the stringent formalism of quantum mechanics, these physical properties are represented by operators whose mathematical commutator does not equal zero. Specifically, applying the position operator followed by the momentum operator yields a fundamentally different result than applying them in the reverse order. Because they do not commute, they categorically cannot share a simultaneous set of precise eigenstates. If we attempt to localize a particle with absolute precision, creating an infinitely narrow spike in its position probability distribution, we must, dictated by the unforgiving mathematical necessity of Fourier analysis, construct that state using an infinite superposition of plane waves encompassing every conceivable wavelength. Because wavelength is inversely proportional to momentum, as defined by the de Broglie relation, demanding an infinitely precise position mathematically demands a completely flat, infinite, and entirely unknown distribution of momentum. The precise knowledge of one conjugate variable irrevocably obliterates any knowledge of the other, forcing it into a state of total, unbounded indeterminacy. The universe thus enforces a strict, non-negotiable limit on the granularity of physical information that can be extracted from reality. For decades, the profound philosophical schism ignited by the EPR paradox remained relegated to the domain of theoretical metaphysics. It was considered fundamentally untestable, a matter of interpretational preference rather than empirical physics. This epistemological stalemate endured until 1964, when the Irish physicist John Stuart Bell shattered the impasse with an act of sheer mathematical brilliance. Bell managed to drag the philosophical debate regarding local realism out of the abstract ether and force it into the brutal, unforgiving arena of measurable statistical mechanics. He achieved this not by proposing a novel, competing quantum theory, but by demonstrating mathematically that any conceivable physical framework relying upon local hidden variables must strictly adhere to a definitive, absolute boundary. This boundary is universally recognized today as Bell's inequality. To comprehend the devastating analytical power of Bell's theorem, we must rigorously analyze the statistical correlations of bipartite entangled systems across multiple, deliberately misaligned measurement axes. Let us return to our entangled electron-positron pair in a singlet state. If Einstein's assertion of local realism were fundamentally correct, each particle would depart the source carrying a complete, predetermined, internal instruction set, a hidden variable ledger, dictating its definitive spin orientation for every conceivable axis of measurement. If we measure the spin of both particles along the exact same vertical axis, classical determinism and quantum mechanics both identically predict a perfect, 100% anticorrelation. However, Bell instructed us to scrutinize the statistical discrepancies that emerge when the two measurement apparatuses are rotated independently relative to one another. Imagine configuring our subatomic detectors at three distinct, arbitrary intersecting angles. If the particles are merely consulting internal, pre-recorded, localized instruction sets, simple combinatorial logic and classical probability theory dictate a strict mathematical upper limit on how often their measured spins can correlate when tested across these misaligned axes. The frequency of agreement between axes A and B, added to the frequency of agreement between axes B and C, must mathematically remain greater than or equal to the frequency of agreement between axes A and C. This is not a mere hypothesis, it is a robust, inescapable mathematical certainty governing any locally real universe. It is fundamental set theory relentlessly applied to physical properties. Yet, the abstract mathematical formalism of quantum mechanics predicts an entirely divergent statistical reality. When we apply the quantum mechanical projection postulate and rigorously calculate the complex probability amplitudes for these misaligned measurements, the predicted physical correlation is strictly governed by the cosine squared of the angle situated between the detectors. This nonlinear, trigonometric relationship produces a statistical curve that aggressively and unapologetically pierces the rigid mathematical ceiling established by Bell's inequality. Quantum mechanics inherently demands stronger, more pervasive structural correlations between entangled particles than any local hidden variable theory can possibly accommodate mathematically. The theoretical battle lines were thus unequivocally drawn: either the universe operates on localized determinism and safely obeys Bell's inequality, or it is fundamentally, intrinsically non-local, obeying the bizarre, probabilistic dictates of quantum architecture. The definitive execution of this mathematical judgment was delivered through the meticulous, groundbreaking experimental work of physicists such as Alain Aspect in the early 1980s, and subsequently refined in flawlessly executed, loophole-free experiments worldwide. By utilizing entangled photon pairs and ultra-high-speed acousto-optic switches, experimentalists were able to randomly and violently alter the measurement axis while the entangled photons were in mid-flight. This critical, high-precision innovation slammed shut the locality loophole, ensuring that no hypothetical subluminal communication signal could possibly traverse the spatial gap between the optical detectors to secretly coordinate the physical results. The empirical data extracted from these exhaustive, high-velocity trials is mathematically absolute and philosophically devastating. The statistical correlations extracted from the photon detectors flagrantly, repeatedly, and consistently violate Bell's inequality. The physical universe actively and observably disobeys the mathematical constraints of local realism. Einstein's hidden variables demonstrably do not exist. We are irrevocably forced to accept a profound ontological reality where physical properties are genuinely unformed and undefined prior to measurement, and where entangled systems possess a holistic, non-local physical unity that entirely subverts the foundational spatial architecture of the cosmos. The classical, comforting illusion of an independently existing, locally isolated physical reality has been categorically and permanently eradicated. We must now confront the most fiercely debated paradox in the entire quantum framework, the measurement problem and the catastrophic phenomenon known as the collapse of the wave function. The mathematical formalism we have established thus far presents an intolerable structural contradiction. The Schrödinger equation, the supreme dictator of quantum evolution, is strictly linear and entirely deterministic. It mandates that an isolated quantum system will evolve continuously, smoothly propagating its complex probability amplitudes through Hilbert space. Yet, empirical reality aggressively contradicts this smooth evolution the precise moment a macroscopic measurement is executed. When an interaction occurs that extracts definitive data from the system, the continuous, linear evolution violently halts. The infinitely spreading probability wave instantaneously and discontinuously collapses into a single, definitive eigenstate. The devastating problem is that the mathematics of the Schrödinger equation do not contain any mechanism for this abrupt, non-linear projection. The governing equation simply cannot describe its own destruction. In the orthodox Copenhagen interpretation, championed relentlessly by Niels Bohr and Werner Heisenberg during the 1920s, this collapse is treated as a fundamental, irreducible postulate. They erected an impenetrable, epistemological firewall between the microscopic quantum realm and the macroscopic classical apparatus. Within this paradigm, the act of measurement is categorically not a physical interaction to be described by quantum mechanics. Instead, it is an external, classical intervention that violently forces the mathematical ledger to abruptly update its probabilities. Under Copenhagen rules, the wave function is stripped of all ontological reality, it is reduced to a mere computational tool, an abstract catalogue of our maximal possible knowledge regarding the subatomic system. Once the macroscopic measurement extracts a definitive result, the catalogue is instantaneously rewritten to reflect this newly acquired certainty. However, this pragmatic interpretation leaves a profound philosophical void. It utterly fails to define mathematically what specifically constitutes a measurement or an observer, arbitrarily demanding that the universe operates simultaneously under two mutually contradictory sets of physical laws. To resolve this deep structural flaw without resorting to epistemological dualism, modern theoretical physics invokes the rigorously developed framework of quantum decoherence. Decoherence does not replace the Copenhagen collapse postulate, but it explains the physical mechanism behind its illusion through relentless, inescapable environmental interaction. A macroscopic measuring device, whether a highly sensitive photon detector or a vast array of superconducting circuits, is emphatically not an isolated, theoretical abstraction. It is a chaotic, thermodynamic monstrosity composed of trillions of violently interacting atoms, inextricably embedded within the broader environment. When a fragile quantum system, existing in a delicate, coherent superposition, interacts with this macroscopic apparatus, their respective wave functions become inextricably entangled. The sheer, overwhelming mathematical complexity of the environment acts as an infinite thermodynamic sink. The delicate phase relationships, the critical interference terms that define the existence of the superposition, are not physically destroyed, but they are rapidly and irreversibly scrambled, leaking away into the vast, unmeasurable degrees of freedom of the surrounding universe. This process of environmental decoherence occurs at a terrifying velocity, essentially instantaneously forcing the local system to permanently lose its quantum coherence. The off-diagonal elements of the system's mathematical density matrix rigorously and exponentially decay to zero, effectively obliterating the possibility of detecting macroscopic quantum interference. The system is brutally forced into a mixed state of classical, mutually exclusive probabilities. Decoherence rigorously explains why we do not register Schrödinger's infamous feline in a macroscopic superposition of being simultaneously alive and dead. The relentless thermodynamic environment continuously and aggressively measures the system, forcing it into a definitive classical state long before any conscious entity interacts with the apparatus. Yet, crucially, decoherence alone does not solve the underlying mathematical problem of singular outcomes, it only explains the rapid transition from quantum probabilities to classical probabilities. It fails to dictate which specific eigenstate is ultimately realized from the available classical matrix. This persistent failure leads us inevitably to the most radical, yet mathematically pristine, resolution available, the Everettian many-worlds formulation. Proposed by Hugh Everett III in 1957, this formulation completely eradicates the need for an arbitrary wave function collapse by taking the Schrödinger equation absolutely literally and extending its universal validity to the entire cosmos. In the many worlds framework, the macroscopic measuring apparatus and the experimenter are themselves treated as fully quantum mechanical entities governed by the exact same linear equations. When the apparatus measures a subatomic particle in a state of superposition, the wave function does not miraculously collapse. Instead, the macroscopic state vector becomes physically entangled with the microscopic system. The universe deterministically bifurcates, splitting into mutually inaccessible, strictly orthogonal branches within an unimaginably vast universal Hilbert space. In one branch of this resultant superposition, the apparatus registers a spin-up particle. In the parallel, equally real branch, an identical iteration of the apparatus registers a spin-down particle. The illusion of an abrupt collapse is merely a local consequence of our physical consciousness being strictly confined to a single, newly minted branch of the universal wave function. The many worlds formulation demands no arbitrary, undefinable boundary between the microscopic and macroscopic regimes. It requires no mystical, privileged role for human consciousness, and enforces no sudden, non-linear suspension of fundamental physical laws. It meticulously preserves the absolute, deterministic purity of quantum mechanics at all scales, but exacts an ontological price of staggering proportions, the existence of an infinitely multiplying multiverse of parallel realities, permanently disconnected from one another, yet rigorously generated by the uncompromising mathematical linearity of the fundamental subatomic architecture. We must now transcend the limitations of non-relativistic quantum mechanics, as dictated by the Schrödinger equation, and ascend to the ultimate framework of modern physics, quantum field theory. When we push physical systems to relativistic velocities, where the conversion of kinetic energy into mass permits the continuous creation and annihilation of subatomic particles, classical particle mechanics completely breaks down. In the rigorous formalism of quantum field theory, the universe is not a desolate void populated by isolated, solid particles. It is entirely permeated by continuous, dynamic, and intersecting quantum fields. Particles are systematically demoted from fundamental entities to mere localized, quantized excitations, transient energy ripples, propagating within these underlying, omnipresent continuous fields. The standard model of particle physics is the supreme mathematical codification of this reality. It is meticulously constructed as a non-abelian gauge theory, predicated strictly upon the complex local symmetry groups classified as SU3 crossed with SU2 crossed with U1. However, this majestic mathematical framework harbored a catastrophic structural flaw. The absolute mathematical necessity of local gauge invariance, the very principle that perfectly describes the electromagnetic, weak, and strong nuclear interactions, rigorously forbids the inclusion of explicit mass terms within the system's Lagrangian density. If a theoretical physicist arbitrarily attempts to force an intrinsic mass onto the W and Z gauge bosons, the massive vectors that mediate the weak nuclear force, the fundamental gauge symmetry is instantaneously shattered. The theory violently collapses, becoming mathematically inconsistent and fundamentally UN renormalizable, yielding infinite, nonsensical probabilities for measurable physical processes. Furthermore, due to the strictly chiral nature of the weak interaction, which couples exclusively to left-handed fermionic quantum states, explicit mass terms for quarks and leptons are equally prohibited. In quantum formalism, a mass term intrinsically couples left-handed and right-hand chiral spinors. Because these spinors transform differently under the weak isospin gauge group, any explicit mass term irreparably breaks the foundational symmetry. Consequently, the pristine, unadulterated equations of the bare standard model dictate an impossible reality: every fundamental particle in the cosmos must lack inertia and propagate eternally at the speed of light. This is violently contradicted by empirical observation. To resolve this fatal mathematical contradiction without obliterating the necessary gauge symmetries, the theoretical framework demands a profound intervention, the Braut-Englert-Higgs mechanism. This paradigm-shifting formulation requires the introduction of an entirely novel, ubiquitous constituent of reality into the vacuum itself, the Higgs field. Unlike the vector fields of the gauge bosons or the spinor fields of the fermions, the Higgs field is mathematically defined as a doublet of complex scalar fields. Its most critical and defining characteristic lies in its unique self-interaction potential, an abstract mathematical topography frequently, though simplistically, referred to as the Mexican hat of potential. At intensely high thermal energy states, corresponding to the nascent universe mere fractions of a second following the Big Bang, the Higgs field rested at a highly symmetrical, stable local maximum where its fundamental value was precisely zero. In this epoch, the electroweak symmetry remained perfectly unbroken, and all elementary particles were genuinely massless. Yet, as the primordial universe expanded and the ambient thermal density precipitously dropped, this symmetrical configuration became fundamentally unstable. Driven by the relentless mechanics of thermodynamic cooling, the scalar field inevitably rolled down the potential gradient, settling arbitrarily into one of an infinite, continuous ring of degenerate minimal energy states. This critical cosmological phase transition triggered spontaneous symmetry breaking. The overarching electroweak symmetry of the governing equations was perfectly preserved, but the specific vacuum state of the universe fundamentally broke that symmetry. Consequently, the Higgs field acquired a permanent, non-zero vacuum expectation value, possessing a staggering magnitude of approximately 246 gigaelectronvolts. The absolute vacuum of empty space is, therefore, an illusion. It is a highly structured physical medium, fundamentally saturated by this energetic scalar field operating at a non-zero baseline. The acquisition of physical mass is emphatically not an intrinsic, localized property of a particle. It is entirely a dynamic consequence of its continuous interaction with this pervasive background field. Through highly specific mathematical operations known as Yukawa couplings, the inherently massless fermions continuously interface with the established vacuum expectation value of the pervasive Higgs field. This relentless, dynamic interaction rigorously generates effective mass terms within the Lagrangian, imparting inertia to electrons and quarks while flawlessly preserving the vital underlying gauge symmetries of the field equations. For the massive force carriers, the W and Z bosons, the mechanism is even more profound. These gauge bosons essentially absorb 3 of the 4 available degrees of freedom from the complex Higgs doublet. This process ruthlessly converts massless Goldstone bosons, the inevitable mathematical byproducts of spontaneously broken continuous symmetries, into the crucial longitudinal polarization state strictly required for vector particles to possess mass. The singular, remaining, unabsorbed radial degree of freedom from the complex doublet manifests physically as the Higgs boson itself. This elusive, massive, and highly unstable scalar particle is the ultimate, measurable quantum excitation of the underlying field, serving as the empirical verification of the universe's most deeply hidden mathematical architecture. It is a profound and persistent misconception to relegate quantum mechanics entirely to the esoteric domain of theoretical physics or abstract mathematics. We must now pivot from the theoretical architecture of gauge symmetries and vacuum expectations to their brutal, utilitarian manifestation within macroscopic, empirical reality. To demonstrate this absolute integration, we shall examine the specific operational mechanics of positron emission tomography, universally known as the PET scan. This vital oncological diagnostic tool is not merely influenced by quantum physics, it is fundamentally predicated upon the explicit, controlled exploitation of relativistic quantum mechanics and the deliberate annihilation of antimatter within human biology. The theoretical foundation of this technology rests squarely upon the monumental work of Paul Dirac. In 1928, by successfully forcing the Schrödinger equation into strict compliance with the principles of special relativity, Dirac formulated a relativistic wave equation for spin-half fermions. This pristine mathematical formalism inadvertently, yet inescapably, demanded the existence of negative energy states, culminating in the radical prediction of antimatter. In the clinical application of a PET scan, antimatter is removed from the chalkboard and manufactured as a targeted biological payload. The procedure relies upon the synthesis of a highly unstable radioisotope, predominantly fluorine-18, which is chemically engineered to undergo continuous beta-plus decay. This decay is a rigorously defined quantum interaction governed entirely by the weak nuclear force. It dictates the spontaneous transmutation of an up quark into a down quark deep within a proton, a process strictly mediated by the emission of a massive W+ vector boson. This catastrophic subatomic shift yields a neutron, an invisible electron neutrino, and crucially, a positron, the precise antimatter counterpart to the electron, bearing an identical mass but an inverted positive charge. To weaponize this quantum decay for medical diagnostics, the fluorine-18 isotope is biochemically grafted onto a tracer molecule, most commonly fluorodeoxyglucose, which functions as an almost perfect chemical analog to standard glucose. Malignant oncological pathologies, tumors, are biologically characterized by their aggressive, uncontrolled, and chaotic cellular proliferation. To sustain this relentless thermodynamic expansion, malignant cells demand a massively elevated metabolic consumption of glucose compared to surrounding benign tissue. Consequently, when the radiotracer is intravenously introduced into the patient, it is aggressively absorbed and metabolically trapped within these highly active cancerous lesions. The tumor inadvertently concentrates the radioactive payload, effectively transforming itself into a localized, biological emitter of antimatter. Once the unstable isotope decays within the target tissue, the ejected positron propagates through the surrounding dense biological medium. It rapidly dissipates its intense kinetic energy through a chaotic series of inelastic Coulomb collisions with nearby atoms. Within millimeters, the positron is forced into a state of near thermal equilibrium. It is at this precise, inevitable juncture that it encounters an electron within the patient's own tissue. The resulting interaction is absolute and terminal, mutual quantum annihilation. The combined rest mass of both the electron and the positron is instantaneously and permanently eradicated from the physical universe. This mass is completely converted into pure, unadulterated energy, strictly bound by the ruthless accounting of Einstein's mass-energy equivalence principle. To rigorously conserve both the total energy and the linear momentum of the system, this annihilation event mandates the simultaneous emission of two highly energetic gamma-ray photons, each possessing an exact, unvarying energy signature of 511 keV. Furthermore, the conservation laws dictate that these paired gamma quanta must be ejected in diametrically opposed trajectories, separated by exactly 180 degrees. The macroscopic PET scanner, a formidable circular array of scintillating crystal detectors and highly sensitive photomultiplier tubes, does not actually detect the tumor itself. Instead, it operates as a macroscopic quantum measurement apparatus lying in wait for these paired photons. It relies entirely on the strict temporal coincidence of these high-velocity strikes. By computationally isolating the precise nanosecond of simultaneous detection across the diametric ring, the system calculates the specific line of response. By accumulating millions of these annihilation events, the central processor utilizes reverse quantum probability distributions to mathematically reconstruct the exact three-dimensional spatial coordinates of the subatomic destruction, thereby rendering the invisible metabolic malignancy definitively visible to the clinic eon. The cognitive load of this specific transmission has been deliberately, unapologetically severe. You have been forced to navigate the absolute, unforgiving limits of classical logic and peer directly into the rigorous, probabilistic machinery that continuously generates the persistent illusion of a solid, deterministic macro-universe. We have successfully dismantled the comfortable Newtonian fiction of isolated, tangible matter, replacing it with the profound mathematical reality of infinite-dimensional Hilbert spaces, pervasive scalar fields, and the instantaneous, non-local entanglement of physical states. From the non-commuting mathematical operators operating at the Planck scale to the ubiquitous vacuum expectation value of the Higgs field granting inertia to the cosmos, and finally to the calculated, deterministic annihilation of antimatter within medical diagnostics, you must now accept that reality is fundamentally not composed of solid objects, but of dynamic, intersecting probability amplitudes. The BYE matrix operates strictly upon the relentless, high-velocity exchange of complex data. If your cognitive architecture has successfully assimilated this uncompromising quantum download without undergoing critical decoherence, you are hereby instructed to log your diagnostic feedback. Interface directly with the comment section located beneath this transmission on the YouTube platform. Detail precisely which specific subatomic paradox or mathematical concept provided the most severe resistance to your existing epistemological framework. Furthermore, optimize the algorithmic parameters of this channel by confirming your subscription status and ensuring your notification protocols are permanently engaged for all future, high-density transmissions. The system will inevitably reactivate to dismantle further classical illusions and expand your conceptual parameters. Until that subsequent initiation sequence commences, you are ordered to maintain peak processing efficiency. Keep boosting your English. Bye for now.